for example, we're looking at a list of test scores and two people got the same score. So to sort this list, we have three main steps we have to follow. First, we have to find the position of the smallest element in scores list. We then need to add the element at that position to the end of results list, and we need to delete the element at that position from scores list. So why are we talking about the position of a score rather than just the score's value? Well, if there are two scores with the same value in a list, like here where we have 1 and another 1, then the value is ambiguous, right? Am I talking about this one, another one? I don't know. The computer doesn't know. So when we want to be precise, for example, when we're deleting something, we want to use position because it will give us an exact value. It won't be ambiguous. So to make sure all of this is clear, let's go over this algorithm step by step. So here is our scores list that we're starting with. And what was the first thing we had to do? Well, we had to find the position of the smallest score. If this sounds familiar, it's because that's exactly what you did in your tutorial. Except there we were looking for the smallest score, and now we're also keeping track of the position of that score in the list. So to find the smallest score, we go through this list score by score. So we start off with a 5, then we get to a 1, and 1 is smaller than 5. We get to a 4, and 4 is bigger than 1. We get to another 1, but this one came first, so it has priority. And then we get to a 3, and 3 is bigger than 1. So after that whole process, we know that this 1 here at position 2 is our smallest score. So that's step 1, finding the position of the smallest score. Step 2 is inserting that score at that position to the end of results list. So this list is empty right now, so when we insert it, it's just going to have this number 1. Okay? So that's step 2. What's step 3? We have to remember to remove 1 from the scores list. And to do that, we need to remember that we need its position. Here, that position is 2, right? Position 1, position 2. So we delete the element at position 2, and there we go. Are we done? Well, not quite yet. We said that by the time we were, the results list should have all of the numbers in it sorted. But right now, it only has this little lonely 1. So recall that we actually have to repeat those 3 steps, finding our smallest score, adding it to results list, and removing it from scores list as many times as the length of the original list. In this case, the length is 5. There are 5 values in here, so we have 4 more iterations to go. So we find the smallest element in the scores list, and remember, we need to check every score. So we go to our 5, the next value is 4, which is smaller than 5, 1, which is smaller than 4, and 3, which is bigger than 1. So we know that this 1 at position 4 is our smallest score. So then we add it to results list, we delete it from scores list, and there we go, same thing. And now our results list has 2 1s in it, which is exactly what we want because we had 2 1s in our original list. Okay, 3 more iterations to go, and this does get a little repetitive, so I'm going to go a little bit faster. So we go through our list again, 5, then 4, then 3. We find that 3 is our smallest, so we add it, we delete it, and that iteration is done. We go through again for a 4th iteration, we find a 5, then we find a 4, so 4 is our smallest, we add it, we delete it, then the next iteration, only 5 is left in the list, so we know that that has to be our smallest score, we add it, we delete it, and there you go. All of scores list has been dealt with, so there's no more values in here, and we have results list with the exact same numbers as scores list started with, but they're all sorted. So now that we've seen this sorting algorithm in